Hi, today we'll solve the problem 1850 minimum adjacent swaps to reach the kth smallest number. So what I will be explaining is the problem statement. We'll go through few examples and then we'll discuss about the solution and then we'll go ahead to the implementation. Okay, let's move to the problem quickly. So you are given a string num representing a large integer and an integer k. So we have a number n represented in string and an integer k. We call some integer wonderful if it is a permutation of the digit in num and is greater in value than that number. So what that does mean is, if I have 1, 2, 3, 4, there should be one permutation to it, like this, and all that, but we call it a permutation wonderful if it's greater than my number. So let's suppose I have 3, 2, 1, 4 and the permutation for it is 1, 2, 3, 4. I will not call it, it is permutation, but I will not call it wonderful. Similarly 4, 1, 2, 3 will be permutation as well, wonderful as well. Now we have to find yeah, and there can be many wonderful integers as we saw. However, we only care about the smaller ones. So what does that mean is, if I have 3, 2, 1, 4, what will be the first smaller one? Smaller permutation wonderful string. It will be 3, 4, 1, 2. How we decided it, we'll come back, but this is greater than this. Okay, this is greater than my number, but I cannot find any permutation. I cannot find any permutation which is which lies between these. So this is become my first, similarly second, similarly third. So that's what it says. So it says, for an example, we have this string, the first smallest will be this, second smallest will be this, and so on. Now what we have to compute is return the minimum number of adjacent digit swaps that need to be applied to num to reach to the kth value. So what will be given is, will be given a num, will be given a k. We have to find the kth smallest permutation, which is wonderful string. And then if I want to convert this num into this string, how many adjacent swaps we need? So adjacent swap is, let's suppose this is 3, 2, 1, 4. This is one adjacent swap. If I want 3, 1, 4 and I change it to 4, 3, 1, 2, then this will be how many adjacent? This moves here, this moves here, this moves here. So 3 adjacent swaps. So this is the problem statement. So if we see, the problem can be broken into 2 steps, step 1 and step 2. Step 1 is take the number, convert that into the kth permutation, which is also wonderful. Once we do that, the second step would be count the number of adjacent swaps required to convert num to set kth permutation of this one. So let's move to the first one first. So let's suppose I have a number 1, 3, 2, 4. Now what will use how will make sure that this get converted into the kth one. So let's see what we have to do for the first one. Then we'll see from the first one we can use it to convert to the second one, because it will be similar. Like, look, this is my 0th permutation. This is my first permutation. Next time I will consider this is at my 0th permutation, and then applying the same rule to this permutation, like the same algo, I will get the second permutation. So let's see how to convert this. To convert this, there is a standard algorithm. What we do is this. Let's suppose this is my number. What we do is we see from backside until, like, suppose this is j. We traverse until we have array j greater than array j minus 1. So, and let's suppose this is the j now, and this is the I is equals to j minus 1. So we know now. So let's take an example. Let's suppose I have a string 1, 2, 3, 4. Sorry, not this one. 4, 3, 2, 1. So I cannot have any permutation which is wonderful to this, right? Because I cannot find any new number to this. So let's suppose this is the string, and this is the string 1, 4, 3, 2, 1. So I cannot actually get anything from this one. I cannot actually make any change to this and get the new permutation with 1 as starting point, and get the next permutation, which is wonderful, because I cannot just reduce it to any permutation which will be less than this. So that's why what we try is we iterate from back until we have j is equals to j greater than j minus 1, and this is the point where we reach. Now what we do, we cannot do anything about this one. We cannot minimize it, or we cannot reduce it. So what we try to reduce this string, and we keep this string as same. So let's suppose I have 5, 9, 1, 4, 2, 3, 1. So this is my jth element. I cannot change this. Even if I change anything to this, that will become smaller. This is my lth element. I will use it to make it smaller, but I don't want to change this, because if I make any change to this one, either it will become smaller or bigger, and I don't want to make it smaller. That will not help me. I don't want to make it bigger also, because I have a way to make it bigger from later positions, like if this position and all. So what we do in this case is, because this is descending, what we do, we reverse it. Now we have this initial part, let's call it x, this ith element, and reversed y part. Why we reversed it? Because we know this is in descending order and we want to keep it minimum. So if we reverse it, this will be in ascending order, and this will give us the smallest one. But now is the main point. In this y, if I replace I with any of the element, any of y element which is greater than I and also smallest in y. So any element in y which is greater than ith element and smallest in y. If I swap those elements, let's suppose this element, I will get the minimum one. Okay, let's see this algorithm with an example. So let's say we have 1 3 4 2 5 6. We want to find the next element to this. So what we'll do, it will be like 1 3 4 2 5 6, traverse from back, check if j is greater than j minus 1. Yes, it is. Replace it. So this is my string. Now in the next iteration, it will be like it's 6 is greater than 5, 6 is greater than 2. Now what we have to do is reverse this string. Sorry again. And replace 2 or swap 2 with the minimum of this string. Minimum of the string is 5, so it will be 1 3 4 5 2 6. So this is how it works. Let's take, just for example, one more example. 1 5 1 5. Yeah, we took that example, like 1 5 3 2 in this case. And let's take 6 as well. So in this case, this is greater than this is greater than this, but 5 is greater than this. So we'll reverse this string. Swap 1 with, this is my I, this is my j. Swap 1 with the minimum of this string. So minimum is here, 6 2 1 3 5, and we'll get the next iteration. So this is the first part. Second part is count how many adjacent swaps we'll need. So this is a simpler part. So let's suppose I have a string 1 3 2 4 1 2 4 3. How many swaps, adjacent swaps, will we require? We'll require only one. Just swap this one with this one. Now let's suppose I have 1 2 5 4 3. I have 1 5 2 4 3. How many steps it will require? It will also require one swap. So let's make it a little bit complex. I just add 5 3 2 4. Okay. So what I have to do is I have to first of all see 2. Let's suppose 1 is in place, 2 is not in place. So we'll search for 2. It's 2 positions from here. What we'll do is we keep on swapping it. So let's suppose 5. I want to find 2. So there is a 2. Then 2 will come here first. 2 3. Then 2 will be swapped with this, and it will become 2 5 3. And then we'll move to the next element. So 5 and 5, 3 and 4, again one swap will required, and so on. So for 2 we added 2 steps. For 4 we added 1 step. So total will be 3 swaps, 3 adjacent swaps. Okay, so this is how we'll solve this problem in 2 steps. So let's move to the coding now, implementation part. So this is we have. So let's start the coding. So let's convert this number into char array because we need the swapping and all that stuff for this. Okay, pattern. This is a kth permutation. Let's take this permutation from a method. It's passing the k, so it will return me the kth permutation. Now just to debug it, what we can do is we can print this to see what actually we got, and then just return adjacent swaps array and kth permutation. Okay, so this is the first step. This is the second step. So here we are converting this array into kth permutation. Here we are just returning the number of swaps. So we can make a copy of it. I'll get this one. So this is what we're doing. We are iterating our string from backcode until what? Until we have descending order, until we find any element which is greater than our which is greater than its previous value. So it will be like let's say if character numeric value from I so until we find a value which is greater than its previous value, we'll just iterate it, and once we find it, we'll just reverse it with I until the end. Keep the algorithm in mind that we discussed. We find out an element which is more than its previous element. Now we are reversing that element until that point. Okay, now what we have to do? So second step in the first one. Once we reversed it, now we have to replace our element with the smallest element in our So this was the first step, reversing it. Second step was reverse this ith element with the smallest of these elements. So how to do it? Smallest of these elements which is greater than I. So any element is y which is greater than I and smallest in y. So let's see for remember that string we have now. This string we have now is in ascending order. Because this was in descending order, we reversed it. Now it's in ascending order. This is what we're doing, is iterating over it. So again, let's use it. So if my character j is greater than my I minus 1 element, should be visible, then the swap okay from j and I minus 1. What we did is also take here, like what we did is in this code. So we reversed it. Now what we are doing is this is ascending. So as soon as I'm iterating over it, as soon as I get some element which is greater than I will just swap it. We can use a binary search for that as also, like because this is in ascending order. Find an element which is greater than this element and just swap it. And now let's move to the second part. Okay, this as well. Now move to the second part, which is counting the adjacent ones. Let's test this first. Let's implement reverse and swap. At least we'll get be sure like this step 1 is working fine. It voice zeros care ij a simple swap. And another one is swap. That was equals, this is swap. This will have same parameters. Okay, so this is swap. This goes. Right, so what we'll do for this is while this is j, just keep on changing them. We can use our swap. Oh, good. Close g minus 1. Let's see if this works. We have system out and let's check for any compile time error. Yes, there is. What's that? Illegal start of expression. Have we missed some closing bracket? Yes, we missed. Cannot find the symbol get found. Okay, this one guys get permutation. Okay, get permutation. And what else we have? Arrays. Is it array A? What happened? Permutation. And we have to just implement this one. Editor. So it will help us to find that, but just for now, we can just we want to test this. Yeah. So finally, yes. So you can see, like for the fourth one, we are getting for the similar one we have here. Let's try for 3. Yes, for it should be, yes, it's same. So that is working for us. We'll see more when we submit it. But now move to the adjacent one. So this is how, this is the second step we moved on, where we'll see where we'll see count of adjacent swaps, and this is very simple method. So let me just write and explain. So let's swap. We have to convert one string into another, but we have to see how many adjacent swaps. So that's important for adjacent swaps. That makes it so if we don't have this until we have this. If it's equal, then we can just ignore and move. But until both the elements in both are not equal, we just add plus plus. What we are doing with this is the same thing. We are searching. Let's again take that example. 2 5 4 3 1. What was it? 1 5 3 to 4. So this is one fine. Will not enter into while loop. This is 2 and 5. Now we'll search where this 2 actually exists in this string, and we'll just keep on swapping it until we match that. So that's how we can find the adjacent swaps. J will point now to 2, while I is greater than J. Simply just keep on swapping. 1, J. As many swaps we do, we just keep on adding them, and then done swaps. Let's see. For 3 it's fine, for 4 it's fine. Should be fine. Yeah, so let's try submitting it. Yeah, so it's working. Just to make it a little faster. Yeah. So thanks guys. Just feel free to comment for any other problem you want me to solve. I can explain with the whiteboard and with the code. Yeah, thank you so much.